Swayam Prabha. Digital India. Educated India.
Hello, Namaste, and welcome to the course on Geographic Information System. This is about the module 7. Till now, when we started our journey from the real world, we actually started it from, if we look at we started it from the real world. We started looking at how we collect data, how we integrate data. Now, once you have the data in your hand, how do we actually store it in a database, how do we retrieve in a database, and what are the different databases that are there, and finally how do we process it to form information. That is what we would be learning about in this particular module. And to be very specific, we would learn what is a database. So once the data comes in, how do we store it, how do we retrieve it, and most importantly, what are the different ways of storing it, different databases that are there, and if time permits, we'll also look at what are the languages that are being used in order to manage this database or query this data from the database. So this is what we would learn in this particular week and the next week. So both of these weeks would be packed with databases. So, and probably in the last week you have also heard about QGIS, the introduction to QGIS. So Prakash did speak about what is QGIS, how QGIS evolved over a period of time, and he did show you some tools that exist in Quantum GIS. So if you can start looking at those tools, if you have downloaded QGIS, or in the practical session, they my TAs would also show you how do you download, how do you utilize the QGIS for analysis of data. But if you can download QGIS and start looking at it, probably database would make more sense in terms of how it is implemented. So in this class we would look at the concepts. For the first and very foremost concept is data. What do you mean by a data, and what do you mean by information? And most of the time most students term data and information to be the same. No, data is different, information is different. So we look at what is data, what is information, what is the difference between both of these. Then database features. If you want to have a database, so what are its features? Then we would look at GIS, geographic aspect or the geographic angle of the database, how it actually differs from a normal database. Then we would also look at if there are any advantages, disadvantages of a database. If there are advantages, what are those advantages, and how it may help us in bettering ourselves in terms of maintaining the files. So instead of maintaining hard files, how do we actually maintain a database so that it would help? Most of us today have access to the, at least most of them who are taking up this course, I would not say all, but most of them have an access to the digital access to most of the ticketing system, banking system, etc. So those are also have developed over the databases itself, the communication of data, database, and as information. So all of these put together also is a database. So in fact most of us are looking at everyday activity in terms of a database itself. So let us learn some of these. So this particular session, now the next two modules are just basics of a database. It is for it is targeted to those people who are understanding GIS and those who do not understand even the basics of database. For people who want to learn advanced databases, I would suggest them to take up the course, which is completely dedicated to how the database, what is a database and how does it work. So more of that terms, but this is just a basic, just to give you a brief flavor of how the database works. So so that it's easier to understand when you are implementing it on using a GIS software. So as I said, when we come to something called as a data and information, so now you go to the field, you have your GPS in your hand, you go to a field, you collect the data. Now you come back and these will be a series of information that is collected. So maybe that you have gone around the entire city, collected the footprints of various buildings, looked at different aspects and recorded all of those. So data is nothing but you have collected a series of facts that can be either sorted or processed or even recorded. Okay, it can finally, once it is processed, it can be even stored. So when we define data, it is the one that is collected based on facts, phenomena or any of those aspects that can be collected, stored, processed and recorded. Data is actually a collection of values. It may be based on perception, it may be based on various other issues, but these are the collection of values that may be in the form of a collected, or it is from the perceived data. But when data gets organized, okay, and processed, it becomes information. So now you have data. Okay, let's say that you have collected all the points in your GPS, you come back to your lab. Okay, then you start working on, you import all those points into your computer system. Once you have imported all the points, then you will start looking at what are the different features. Maybe you have a background as a Google map or any of those reference values. So now what you will try to do is that you will start digitizing these points and say that this is what I have collected, this is what is the quantitative value, this is a qualitative value. Okay, once you have collected it, you will process to obtain certain information out of it, maybe using a raster processing, using some other raster data, satellite data or any other data. Okay, you just get some values out of it, a qualitative, quantitative information, and you process that information. Now that becomes an information. Once you have processed it, it becomes an information. So those are the values which are stored as information. Okay, so when when this information is processed, normally it gives a generalized conclusions. So you should be very specific. So not always information is a very specific conclusion. It is most probably a generalized conclusion of all the data that you have concluded. You would not say I have taken this particular building, this particular site, that particular building. So if you are pinpointing each of this information, storing as different values, then it is a specific information. Otherwise it is a conclusion of all the data that you may have collected and stored in your GPS and processed in your computer system. Now when we look at data and information, data is about raw facts. Okay, so they may be there, most probably most of the data won't be of context. Okay, but when you look at it, it may be numbers, it may be text, it may be GPS traces, it may be your just in photograph informations, or it may be your high altitude, low altitude photographs that you may have taken at that particular of time. But once that data comes into your lab and comes into your system, you connect the data with context. You will say this particular building is somewhere next to this particular place in this particular street. Okay, so or it has this is the latitude, longitude, and this is street, and this is where you collected the data. Okay, and data is all of these data. It has 7 floors, it has maybe some of those data you would have collected. So it is a data with context. Okay, then when you look at information, it is the one that is processed after you have got data. So when you look at information, it is information is at least it is a processed information and a generalized information, generalized conclusion. Normally informations are value based data. Rather than when you look at data, these do not have a value. It has to be processed to be get a value. So informations are those which have value base. So that is the difference between a data and information. So when you are speaking next time to anyone, so be careful that how do you define a data, how do you define a information. Okay, so to go ahead with the same thing, data can be any character, number, images, words. So it can be anything. It can be based on records and observations also. Many a times most of the data is collected based on records, based on various information from the governmental records, and say certain observations. There may be hundreds of observations that people would have done over a period of time and recorded it. That can be converted into a digital form, that becomes a data. So this is what we mean by a data. So when you look at the information is an analysis of whatever the data has come. Information is organized and processed. So information is always organized, okay, and is entire and has certain process. So when we give a generalized structure for this, you have a huge number of data here. Okay, we have a lot of data, and when we process it, it forms an information. This is a generalized form of how we say how a data is converted into a information. Now when we look at a database, now we have understood data. Next is the base, which means to say that it is a storage system where for that particular data. So when we look at database is an organized collection of data stored and accessed from a computer system. A database can also be on a physical records, so that also can be a database. If for example the file, for example there are attendance systems in many schools or in many institutions where physically the attendance is marked, that's also a database. Okay, that's a physical records that have been maintained over a period of time. If the same attendance system is maybe put it or may have been stored in the form of a thumbprint, when many of institutions now have sensing system where thumbprints are used to give attendance, so that there is no inconsistency in the attendance system. So if that is the case, then you have a digital form of the database. So you can have a physical form, you can have a form that is stored in the system also. Both are called as a database. Okay, and when you look at computer database, these are more efficient, and if they have to be efficient, it has to be properly designed. Okay, so if it has to be properly designed, then the correct modeling techniques have to be involved in terms of designing of that particular database. Okay, so when I say a database, when I say a database, it is where your data is stored to be processed. That's nothing but a database, as simple as that. Okay, so you have your attendance system where a particular teacher or a tutor marks your attendance, and that particular attendance may be processed at end of your examination, or when you write your exams to see how much is your total attendance and whether you have a shortage or not. So that is nothing but a database. Okay, now when if the shortage information is given, how much percentage of shortage you have, then it means to say that it is nothing but information that is processed and given from that particular database. Now when we look at the database system, so when I say system, it is the software, hardware, etc. It's an entire system where data comes in, is processed, is then delivered. So that is nothing but a system. Okay, so when I look at the database systems, these are normally designed to store large bodies of information. It is an organized body that stores related informations. Okay, when I am very specific here, stores related informations, not junk. Okay, in addition, it must provide for the safety of information stored. This is very essential in today's context. So safety of information that is stored is essentially very integral part of database development. If you are able to give a security aspect to your database, then probably your database would be more secure in terms of illegal surfing that may have happened on your database. So in the face of a system crashes or attempts to unauthorized access, you may have to save it. So you may have multiple locations of looking at it, or those most of the database nowadays are stored in a cloud connected systems, so that any even in the physical systems that user uses, if it actually shuts down, or if it's under repair or system crashes, so you will always have you will not have any issues when you are handling that system, and always a backup of that database is made, always, and maybe a backup on any of the cloud systems are made. So when you look at database and a database systems, so database is where it is stored, it is the way it has algorithms, it has the way it has to be stored, but the database system is a collection of how this database is organized. And when we look at data and database system, these have become an essential component in everyday life. When you look at for example, we encounter several activities when we look at interaction of the database. Very common activity that you may see is, for example, most of us would have looked at Amazon, we would looked at Flipkart. So when you are actually surfing all those items on this Amazon, Flipkart, Smart Deal, Snapdeal, all this stuff, so what are you trying to do is that you are actually accessing their database to look at what are the items that are there for sale. Okay, so different vendors. So now you have different vendors, each of these vendors have different items for sale, and each of these items have their own way of representations. Okay, own constraints, own way of representation, own policy, etc. So each of these become a database. Okay, so data in a database. So now you have several datas in the database. Now you select whichever you need, you then connect it to the database, which wherever the Amazon server is located. So you talk with the database and say you want to buy this, and that once you have connected this, it asks for your address that may be stored again in one of the servers of Amazon, okay, or one of the cloud systems of Amazon. So now once that is done, then it redirects you to your payment gateway, which may be some of the banking servers where again your database is stored. So when you are giving your particular UPI address or your net banking value, it is going into that particular server, accessing that database. Only the things that are visible to that particular server is accessed, and once you give authorization, it deducts your whatever the value that has to be deducted. So this is how the chain that normally works. So that is what you are trying to do in everyday life. Or even if you are going and trying to look at your mini passbook in an ATM and you try to take a printout, okay, you can take a printout of whatever is last 10 transactions. So what are you trying to do? You are actually trying to access the database, collect the information of all the transactions that has happened in last maybe in last 10 transactions. That is nothing but you are querying in the database. You have stored some information, bank has collected data about you, has stored certain information there based on your transactions, and you are accessing that database in order to get that information. That is exactly what a database system does, a database does, and how the information will be. Okay, most of us are involved in this digital era in terms of daily interactions with the database and database system. And if you want to look at very good examples of the database system, banking system is a very good example of a database system. You could even see that there is a lot of issues that is happening. Sometimes the system is down, maybe there is upgradation, or someone has an unauthorized access to that system. There is online railway now. If you look at the railway system, with the digital network that has improved and the digitization that has improved, you can see the previous the railway platform and today's railway platform is much better in terms of user friendliness and how you actually start booking a particular ticket on that particular IRCTC website. So similarly, different website been given an access in order to book that particular railway ticket. It means to say that there are multiple instances which are actually looking at that particular database. So this is a wonderful thing of how a database can help multiplicity of users. They will normally do not have any count or number of users who can get into the database, but they look at the security of information, the amount of information that has to be leveraged, and amount of information that is necessary for a particular operation to happen. Similarly, when you look at hotels, when you look at airlines, so all of these have a certain ways of interactions of database. They are very well known system. If you look at your some of the libraries of your schools which are completely computerized, wherein you go, you look at the title of the book and where the shelf it is actually kept. So that is one way of accessing your accessing the database of that library of that institution. Then some institutes have ERP, and probably in some days IIT Kanpur is going to develop ERP for the or most of the institutes across India, or a platform that is generalized platform for most of the institute. You can see there is an this image is showing the ERP system of IIT Kanpur, which again the entire thing is a database. It has student information, it has faculty information, it has information about different aspects of a particular department. Certain access is given to certain faculty, certain access is given to students, there is certain access only to the administrators. So this also is evolving over a period of time, and and helping it to become more of a paperless transaction over a period of time. So this is one very good example that even IIT Kanpur is having a very efficient system in terms of ERP. And other very good example is nowadays the online exams that has come up and the results that show up. So these are also a good example of how the data is processed as a database, and how do you have the information in terms of results that would have been processed. Once we have understood what is a database, what is a database system, now database management system. So you have to manage that database, right? So in order to manage that database, it is a computerized management system. When I say database management system, data management system, okay. So it is an application that helps you to store, retrieve, analyze, sort and print information in a database. So it can be also called as a software, or it can be called as an application to create, maintain and access a database, okay. So that is nothing but a database management system. Now data is different, database is different, database system is different, and database management system itself is different. So it is an application. So you should understand all of these concepts, and then only you will be able to handle most of your data in terms of attribute data that you have for any of those calculations that you want to make. Then you have a features of databases. When you look at features of database, the very important features is data independence. So when you look at the entire database, data independence becomes a very important part of any database. So most data that is stored are independent in terms of the way they are stored. And data integrity, so that is another aspect. When you look at the integrity of any data is very essential in terms of maintaining the entire database. So data integrity becomes a very important feature of the database. Then you have flexibility, then easy accessibility. So whatever the example that I give are very good example of easily accessible. So once you have connected to that database through your 4G network, you have easy accessibility to whatever the information that you need, okay. If you need something administrative information, definitely you have to go to the bank, but unless you are at your own access level, so you can get all the information that is necessary, which is easily available. And very important aspect to user is these are very informative in terms of information that is required. The big informative database system that you can most of us always look at is the Wikipedia. Okay, if you look at the Wikipedia part of it, these are huge number of users who actually maintain the entire database, who edit regularly the database, who add information to the database, okay. So that is accessed by us as a processed information. So that information is then can be used by any people to understand what is that particular concept. So a very good example of a database system. Okay, so when we look at a database management system, we have certain advantage of when we look at database also. One is it is non-redundant, data independent, they are not they are not dependent on what kind of data it is. Then program usage, that is also quite essential. It is advantageous in terms of different programs and usage. Then interrelationships is what matters. When there are a lot of interrelationship among the data, among the database, and among various sets of database, so it is much easier to handle in terms of relations that exist across the data sets. So when we look at database and geographical context, so both of these are quite related in terms of how they are being processed. And when you look at the database, it can contain a geographic data of a particular subject of a particular area. So when you look at the difference between a database and a geographic data, for example, if we look at this specific thing, they are quite related in terms of how they are stored. But when you have data, when you have GIS, it actually links whatever the attribute information you have with the spatial information. Okay, spatial information is stored in different models, so you have different models and connected attribute data. So when you look at attribute data, these are normally flat files or files that may have numbers or just information, quantitative, qualitative data which are there. So these are just attribute informations. Then these attribute data can be related in form of a relations, equal to, greater than, less than, or it is related to something else. So these are the two things that attribute data may have. But when you look at map data, that is in the spatial form, has point, line, polygon. It may have a topology that is built in already. It may have thematic information that has been built or processed over a period of time. So combining both of these and putting it on the database is nothing but geographic database or GIS database. So connecting a geographic information with the attribute information or the keys that are there in the entire database is nothing but you are using a GIS database. Okay, we will learn, we will also use we will create ourselves a particular vector layer. Then we look at how we can manipulate that, then how can we store it as a database, then how will we manipulate that particular database, how will you use attribute data to quantify certain things like area, etc. Then how do we actually show that attribute data as a factor in terms of relating it to your on ground situation. So all of this we'll look at in the practical class, wherein we would do an hands on each of these aspects. And when we look at advantages of database over files, the very important advantage is it avoids redundancy. Okay, let me go to the next slide. Maybe I'll show you in my next set of slides, which actually tells you what kind of redundancy may happen. Okay, but as of now, let us think that it avoids redundancy and duplication. Duplication in terms of, for example, if you have a file for a particular purpose, now you keep on if someone doesn't know and creates another file in the same context, so that becomes a duplication of the same set of files. If the papers are different, it is redundant file, but if the papers are the same, then it becomes a duplicate file. And when you reduce data maintenance cost, that is very important in terms of maintaining a data. Then faster for very large data sets. If you have extreme, with today's computing capability, it is when you have a good database designed in good modeling system, then it is extremely faster. Applications are separated from the data. Very different applications are different, and data is different, and database is different. So applications persist over time, so there is no constraint of time. Then you have support of multiple concurrent applications. So that's, we'll look at it, look at how multiple applications can run over a period of time. Then you have better data sharing. Okay, so you can share your data in a better way in terms of access of data and sharing of data. Databases provide extreme flexibility. Security and standards can be defined and enforced. I said in today's context, security and security is an extremely important aspect of sharing a data. So then now the concept of standard has also evolved over a period of time. Standard is extremely important in order to have the data. For example, the way first of all the data is saved, where when you are saving it in terms of particular file format, so those file format have also a standard way of recording that data. So these are normally under the convention of OGC, Open Geospatial Standards, so or Open Geospatial Consortium standards. Based on these standards, this data has to be stored. Okay, so if we look at these standards, it has evolved over a period of time, and India is actually also looking at how we have maintained, enforce these standards in terms of the development of the spatial data. And also when we look at the interoperability of all your data, all your tools that you have developed, so they need to be interoperable in all the environments, in all different forms. So to make it interoperable, you need certain standards. So these are those standards that have also been evolved over a period of time. So both of these go hand in hand when you look at both security and standard. If standard is maintained, there is some part of security aspect is also taken care of in terms of development of that particular database. And when we look at, always any system has certain disadvantages. When we look at a disadvantage of a database, it is expensive. That's the maintenance expense. So if you are looking at a long term, it may not be expensive, but if you are looking at a short term measure, database may be quite expensive. And complexity involved, only until unless you understand it thoroughly about how do you maintain a database, what kind of database it is, how it evolves over a period of time, what is the data that is fed in, how you are connecting it with relationship, what kind of relationship, etc. If you are not able to understand as a computer engineer, so then the complexity is quite high. Once you have understood the entire complex database, then it may be just child's play, but unless it is understood, it is highly complex. Then performance, especially the complex data types. Handling a complex data type is extremely it's a huge task, and when it comes to spatial data, it is really a task that is the order of the day. So if you are very good at handling complex data in a very big complex database, then probably that's the best thing that you can do in terms of GIS. Then integration with other systems can be difficult in many times. So that's why we are now the standards have been developed. If it is evolving over period, it's not quite developed, but it is evolving over a period of time. At maybe in some point of time, most of the integration can be done from any system to any other system. So it is evolving, but it needs some time to evolve to get to that extent. So in summary, we looked at what is a data, what is information. So we looked at data versus information. We also looked at what is a database. So we started with data, then looked at the database, then we looked at what is a database system. Then once you have looked at the database, we also looked at database management system. Okay, so then we covered how a GIS and a database matches each other, how a geographical input and a database management system are can be interlinked. When I say geographical system, it is point, line, polygon, topology, or any of those features. And when you look at a database, it is boast of attribute data and how the attribute data is interacting with each other through relations. So when we combine both of these, this forms the geographical database. Then we looked at what are advantages and disadvantages. So when we come into the next class, probably we'll look at more into how a database management system works and what are the different databases, what kind of relationships are there, what are different forms of storing your data, and how we access this particular data. So let's meet in the next session, next lecture. Thank you very much.